Welcome to the Bug Bash podcast, where we talk about all things software correctness and reliability. I'm your host, David Wynn. AI coding assistants promise incredible speed, but what happens when you run straight into a wall of buggy code and technical debt? In this episode, Clare Sudbery, a software engineer with over 25 years of experience, discusses a crucial paradox for modern developers. The secret to harnessing AI's power isn't to move faster, but to slow down. Clare explains why deliberate, rigorous practices like test-driven development are the essential guardrails needed to guide AI tools toward reliable, high-quality software. You'll learn why more, smaller steps is the key to tackling technical debt, and how throwing away your code might be the most productive thing you do all week. Stick around.
Hello, welcome to the show, Claire. Why don't you start by introducing yourself to us?
Hello. So my name's Clare Sudbery. I am an independent technical coach. And what that means is that I actually travel all over the world, working both online and offline with software engineers and events, teaching good software engineering practices. I've been a software engineer for more than 25 years. I've stopped trying to count. And I have a particular interest in teaching. So I really love teaching and mentoring, and this is what I do. I help people to get better at software engineering, and I'm very lucky that I happen to enjoy doing that.
Wow, well, thank you for being with us today. I am very excited about the coming hour. Looking forward to learning from you. So I want to start by asking you actually a fun question.
Mhm,
If bugs were actual insects,
mhm.
what kind of a bug would a race condition be, and why?
Okay, so I have had a heads up because you did tell me that you're going to answer this question. So this is why I do already have an answer. I was actually at an event in Manchester this week. So Manchester Tech, I live in Manchester in the UK, and it was Manchester Tech Festival this week. And the building that it was hosted in is an old Victorian swimming baths with beautiful tiled walls, but it's also very old and it's very dilapidated, and it's only just going. So it got closed down and they had to have a big campaign to get funding, all of which is to tell you that it's quite a basic building. And I wasn't at all surprised to find spiders in the toilets, in fact. And there were these three giant, really, really big. They're called huntsmen. No, not huntsmen. No, those are the Australian ones. Definitely not huntsmen. Even I'm not scared of spiders, but if they were huntsmen, I would have run away screaming. No, not huntsmen, harvestmen. And the harvestman spiders actually technically not spiders. They have these tiny, tiny little bodies and very, very long, thin legs. And what they do is they sit on walls and they kind of splat themselves completely flat. So they're almost like kind of stars with these tiny blobs in the middle and then these legs radiating outwards and creating these kind of circles. And the reason I mention them is that on this particular wall, there were three of them. And they were kind of interlaced, so they weren't separated from each other. Their legs were kind of crossing each other, and they were always kind of sitting on top of each other. And this was what I thought of when you said race conditions, because of course the problem with the race condition is that you've got more than one thread trying to access the same resource and potentially accessing that resource out of order, so that one thread doesn't get the results they expect because another thread has accessed the same resource. And in this case, these spiders were all trying to access the same resource. They were both trying to occupy the same bit of wall. So I'm going to say a race condition is these three harvestman spiders on a wall. But having said that, after I came up with that answer, I then got way too clever and started thinking, but the thing is, are the spiders the race condition? The spiders are creating a race condition. The spiders are all trying to access the same resource, but they themselves are not the race condition. And can I think of a bug that actually is? And then my brain exploded, and the answer is no.
Wow. Wow. That is so way more than I expected. That's great. So let us talk about you've been in the industry for a very long time, and you're an enthusiast about TDD and testing. I want to ask you actually like a question about when ChatGPT first became wildly available. What was your gut reaction as someone who spent years like advocating for TDD? Did you like think that, oh, this is going to change everything? Or did you feel like, oh, this is just going to make things better?
Now, interestingly, I was highly skeptical. So just in case, because sometimes when people say TDD, it sounds a lot like DDD. So just to be clear, what we're talking about is test-driven development. And the thing about test-driven development, and not just test-driven development, but all coding, is it requires a huge amount of thought. It requires a huge amount of collaboration. It's never as simple as just writing some lines of code. You have to think about how you're going to integrate with a wider environment. And when you're writing tests, you have to think quite holistically. You have to think about the meaning. You have to think about what are you trying to achieve with this code. And it seemed really unlikely to me that an LLM would be able to do all of that. Because, and when you think about not just ChatGPT, I mean, in fact, if you're coding, then you're using GPT, which is the LLM behind ChatGPT, or you're using Gemini or SWE or Claude. And what blows my mind about LLMs is all they are doing, really, fundamentally, all they are doing is telling you the next most likely token, and where a token is just a chunk of text. And what they've got is a huge wealth of text that they have been trained on. And particularly when you're talking about LLMs like Claude, which are more kind of deliberately aimed towards coding, they've been trained on, but all of the ones that are used for coding, they've been trained on code. They've seen code, but it's just characters. It's just words. All they've done is they've got a huge quantity of it, and they've worked out what are the next most likely tokens. What are the next most likely characters and keywords? And they're guessing. They're guessing based on statistics. They're guessing based on probability of what might come next. It is astonishing because they're very good at it. They make very good guesses, and it is very, very clever. But they're not actually thinking. They're just looking for patterns. And at first I was like, I mean, this is ridiculous. Like what's going to happen is people are going to, and what has happened is people are going to believe they're talking to something intelligent and sentient that's making decisions on the same basis as they would. So it feels like the LLM is choosing a particular line of code or a particular routine because it's thinking like I would if I was making those choices. But no, it isn't. It's just statistical. It's just probability. It's not thinking about it like I would think about it. And the obvious flaw in that is that they're just going to make crazy decisions. And they do. They absolutely do make crazy decisions. They do crazy shit. And you're like, well, I mean, why on earth would I put my project in the hands of this kind of nonsense? And also my experience, so not just based on what I might expect, my experience is that when you try and do test-driven development with an LLM, you get funny and ridiculous results. So I'll give you an example. The very first time I experimented with coding with an LLM, because of my background, because of the way I think about code, the obvious choice was a kata, a small coding kata. Now, actually, I wouldn't recommend that to people. Like, LLM's not very useful for katas, because typically, if you're doing a kata, if you're like me and you prefer test-driven development, and generally katas are kind of designed to encourage the use of test-driven development, what you're doing is you're writing a tiny test for you're thinking about what is the tiniest, smallest, simplest thing I can test. So you typically start with 0 or an empty case or something that is just trivial. You write the test and then you write the code to make the test pass. Now, you can do this with LLMs. You can write a code and then get the LLM to write a test, and then write the code, get the LLM to write the code to make the test pass. And you can also ask the LLM to write a test. And that's where it all starts to go a bit haywire. Now, the reason I wouldn't recommend that is because that means you're moving very slowly. And actually and even though moving slowly is a good thing, moving in tiny steps is a good thing, you're not really harnessing the power of an LLM when you move in those tiny steps. So what I did, because I was deliberately experimenting, I wanted to try lots of approaches. So I wanted to try the absolute standard, write a tiny test, write some code, make the test pass. I wanted to do that, but I also wanted to find out what would happen if I just said to the LLM, write the code to make this work. So I started with FizzBuzz. If you've come across FizzBuzz, I'll explain it in case the listeners don't know. FizzBuzz is actually a game that's played in classrooms with children. It's a very popular game for people who work with elementary school, primary school children, and secondary, high school as well. I used to be a high school teacher. It's surprising how much teenagers like this game. But what you do is you get everybody in the class to take it in turns to say a number. And what you're doing is you're counting from 1 to 100. But when you get to a multiple of 3 or 5, you don't say the number. So for a multiple of 3, you say fizz. For a multiple of 5, you say buzz. For a multiple of 3 and 5, i.e. a multiple of 15, you say fizz buzz. So it goes 1, 2, fizz, 4, buzz. So I've already got lost. Fizz. But anyway, it's actually quite difficult.
It is hard.
So I said to the LLM, write me some code that will output the numbers from 1 to 100, but multiples of 3 are fizz, 5 is buzz, 15 is fizz buzz. It wrote the code. And then I said, and honestly, I didn't look at it because that wasn't my objective at that point. It was, I then said, now write me some tests that prove that your code works. So it wrote some tests. And again, I didn't look at the code. I was looking at the results, the outcome. So I said, right, okay, now I'm going to run the tests. I ran the tests and they failed. Now, I thought, right, okay, well, this means that It's written bad code. Also, and I'd already spotted while these tests were being generated, I could see, because it tells you get this output. It's saying, now I'm writing tests that test this, and now I'm writing tests that test that, and now I'm writing tests that test that. And it had got completely carried away. There was clearly a lot of duplication. It was writing tests that were testing things that had already been tested. It was writing things from every possible angle that it could think of. It was a bloated test suite. But those tests were failing. So again, I thought, right, okay, the whole point here is that I'm trying to discover how the LLM can make my life easier as a software engineer. So I'm not going to read those tests any more than I read the original code. I'm going to pass the buck back again, and I'm going to say these tests are failing. Why are these tests failing? And in that kind of obsequious way they have is, oh, yes, I'm terribly sorry. You're right. Yes, the tests are failing. Why are the tests failing? And now I was already intrigued. I'd started to look at the code. And I could see that these tests were commented. And the comments were saying it was, and this is the weird thing, it's so hard you have to keep reminding yourself it is not thinking, not like I do. But it had added comments that were saying things like, well, I think maybe I should test this. Yes, but also maybe I should test that. And in the midst of it all, it had added a little kind of stream of consciousness. Way too many comments, by the way. Not very clean code. But it had added this little stream of consciousness that was like, well, it's always a good idea to use zero-based numbering systems. So it was counting from 0. And then in its test, it was saying, well, because I started at 0, that means that 99 is a multiple of 5. Because 99 represents 100, yeah? So therefore, 99 is buzz, because it's a multiple of 5. But one of its other tests was saying 99 is a multiple of 3. So 99 is fizz. And it had both tests. So these tests were contradicting each other. So obviously one of them was going to fail. Now, it turned out that the original code it had written, though horrible code, was correct in that it was doing the job I'd asked it to do. And so the test that said 99 is buzz was failing. But when I asked it to fix the failing tests, it came back to me and it said, oh, yes, I see what the problem is. The problem is that this test says that 99 should be fizz, and that's wrong. 99 should be buzz, because we started counting at 0. I was like, whoa. Okay. So, so to go back to the original question, it wasn't doing a great job. First of all, its tests were bloated. They were duplicative. Second of all, it had misunderstood how to cope with 0 indexing. And also, it hadn't even questioned the fact that I got it to write the code before it wrote the tests, rather than doing it the other way around. So on that level, it's really not done a great job. But what I can do is train it to do a good job. I can give it rules. Again, it feels like I'm having a conversation with it. It's not, I'm not in the same way as I would with a real person. But I can say to it, you know what? There were problems in this process. Let's look at what those problems are, and let's do it different next time, and let's document it. So I can have a conversation in inverted commas with the LLM where I say, you know what, in future, I would like us to write tests first, and I would like us to make those tests one at a time, and I'd like to move slowly, and I'd like to move in small increments. I'd like you to give me the opportunity to commit whenever we make a new test pass. I don't want to trust it to commit. I never want to trust it to commit, to be honest. But there, I can have that conversation with it, and then I can say, let's document that conversation that we just had. Let's turn that into a list of rules, and it can do that for me. And then I'll edit those rules typically, because they're not going to be quite fit for purpose. But again, I didn't have to do all that work myself. And this is something that's changed really in the last 6 months, that we're able to do this and we're able to do it effectively. And it's going to keep changing. So, sorry, I have just talked and talked and talked. You've probably got other questions on the back of that, and I'm not even sure I answered your original question. But
I think like we're onto something here. Like I wanted to like dig deeper here and ask, how do you foresee our workflow with like evolving over time, particularly like around writing tests and test-driven development with the LLM tools out there, Cloud Code, Cursor, all of the other tools? Like, what do you foresee happening? How do you, like, 3 years from now, what do you expect, and how do you think we should evolve there? And maybe you could tell me, like, what is the bad way we could evolve, and what's like the good way we could evolve? Like,
yeah, that's a great question. The bad way and the good way. The honest answer is 3 years is a long time, and I don't know. I am not a fortune teller, and whatever I tell you, I will almost certainly be wrong. But I can guess. I think that one of the things that I'm seeing is that people who are really seriously making use of agentic AI use in software development are realizing very quickly that you really do need guardrails. You need a human in the loop. So it is absolutely possible, and I've done it, and it's scary to say to an LLM, write me an app that does this, and it will just do it. It will go away and write an app, a deployable app. Now, I mean, granted, we're talking small apps here, but you know, hobby projects. Yeah, you can. It will come back to you with an HTML file that's got embedded JavaScript that you can absolutely put into a browser that will do the thing, that's got a UI and will do the thing that you want it to do. And people are doing this with hobby projects, and that's absolutely fine. But these are just little hobby projects. If you are actually in the business of writing commercial deployable software, you want to be very, very cautious, because it's a little bit too easy. to do that. And I think that you said what are the bad possibilities and the good possibilities. The bad possibilities, and it's not even a possibility; it's an inevitability. It's that we are going to be flooded with terrible apps that absolutely kind of do what we want them to, but got massive security holes, terrible UX, kind of half work. I mean, I got it to write an app for me the other day that at first I was really excited because it did it in a couple of minutes. I was, oh my God, look. And then I started trying to use it and I was like, no, but no, that's wrong. And well, that's a bit of a tangent. I'll come on to how I dealt with that in a bit. But yeah, they're not fit for purpose. They have problems with security. They have problems with deployability. They have problems with scalability. They have all the problems that you would expect an app built by somebody who wasn't experienced in building apps to have, because they've been trained on all the code, which includes all the bad code. And I'm sorry, but most code is bad code. And because there are lots of reasons why people write code too quickly with too few constraints, and so most of the code out there is not good code, and they don't know. It's just the next most likely token based on what it's seen, and what it's seen is mostly bad. So what do we do about that? So what I'm seeing is, for instance, there's an organisation in the UK called DEFRA, who are a government body. Can't remember exactly what it stands for, but it's something to do with farming and agriculture. They do things to do with farms and agriculture, like all organisations. They need to build code in the midst of all of that. They build tools that people use to do with farming and agriculture. It doesn't really matter what. But they're a government body. They're a serious body. They have high standards, and they're accountable to a whole set of important structures and laws. And they have started using AI in their digital department. So when they're building software, and they very quickly realized that they had to put guardrails around it, that they couldn't just trust it. And they also very quickly realized that in order to do that, going back to basics, thinking about things like test-driven development, thinking about moving in small steps, thinking about having good source control, thinking about having good branching strategies, all of these things were really, really important in building quality software with AI. And when you're trusting something that isn't entirely trustworthy, or in fact isn't very trustworthy at all, then all of that stuff becomes even more important. So what they discovered was that they had to pay much, because they kind of paid lip service to test-driven development, like a lot of people do, but they had to start taking it a lot more seriously. And I think that there's probably going to be a kind of almost a two-tier system. And that's not actually a big change to how software development already is, because there are already a lot of people who use really great techniques and a lot of people who don't. And I think it's almost going to be like the rich get richer and the poor get poorer. The gap between the good software and the bad software might get even wider. But there are going to be a lot of major security incidents. There are going to be a lot of major system failures. There are going to be a lot of shoddy systems out there that haven't taken account of good software engineering practice, that haven't had good oversight, that haven't had people really paying attention, because it's so easy. And so that was what I wanted to come back to before. What did I do when I asked the LLM to build me an app that wasn't fit for purpose? And the answer is, and also it's also worth me saying that this was, I was kind of doing it for fun, and I got sucked in. So, the rabbit hole of the, well, I should go to bed now, but I'm having fun and I want it to work. So I'm just going to do another 10 minutes and then another 10 minutes. And literally I didn't go to bed until 4:30 a.m. Because I couldn't stop. But because it was getting later and later and I was getting more and more sucked in, my judgment was getting worse and worse. And I just kept saying to it, no, that doesn't work. No, that doesn't work. No, that doesn't work. And it kept saying, oh, well, that's fine. I'll fix it. And it kept making it worse. It was getting worse and worse. We were getting further and further away from where I wanted to be. But even within that small space of time, I mean, less than a day's worth of work, because I'd started quite late anyway, the sunk cost fallacy was kicking in. I was like, but it's built me an app. I have an app that sort of almost works. So I don't want to throw it away because here it is. It's a thing. It's a thing that's kind of almost does. So we'll just keep trying.
Keep going.
And it was,
keep going.
Yeah, keep going. And it was getting worse and worse and worse. What I should have done and what you can do with LLMs, and it's really useful, is stop, throw it away, start again.
Amazing.
Which is a wonderful technique. But I got pulled in, and that's what happens. You get sucked into just a little bit more, and then it'll work. And then at one point, I said to it, right, write me a bunch of tests, and they were just horrendous, just the worst tests. Go on, no, carry on.
You reminded me actually with the Dora report just came out, I think, a couple of days ago.
Yes.
And what you said just reminded me of what I think the report said, which is AI is going to amplify your like DevOps process. If it's good, it's going to be good. If it's bad, it's going to amplify your bad.
Yes.
And that's what you're saying right there is how it can make the poor and the rich richer in software health kind of way.
Yeah, and it can encourage you into bad practices. But anyway, go on, carry on.
Going to the last thing you just said about how you got sucked in and stayed until 4:30 a.m. in the morning trying to make this work. Did it actually make you productive, or do you feel like actually if you approach it differently, it would have been a better way? Like you said, throw it away and start again. Is test-driven development and AI something that a combination that could eventually be productive if you use it the right way, or but this experience does not give you hope that it's possible?
I believe it is possible, but in this instance, it did not make me productive. And I'm actually, because I'm very interested in trying to find out whether LLMs can help you to be productive. I'm deliberately measuring everything at the moment. So I'm doing really granular time sheeting where I make a note of how much time each step takes and what I do and how long it takes. And so in a few of my projects, what I do is I'll build something by hand and then I'll build it again using an LLM, and then I'll do it the other way around because, of course, the problem is that once I've built it myself, I know things that I wouldn't have known, which is going to inform the process. So sometimes I'll build similar things rather than the same thing. And so far, typically, I can do it faster on my own. And it's certainly in that example, that particular app, it was slower to use the LLM because what happened was, 4 of those hours were between midnight and 4 a.m. and I wasn't making progress.
Of course.
I thought I was, I felt like I was, but I wasn't. Now, interestingly, at the end of it, I did have a usable tool, but it only had half the functionality I wanted it to have. And that usable tool I got when I went back to a previous commit that had been made 3 hours ago, and that was the last good state. And at that point, we did have a usable tool. And, I kept that. And I did actually literally use it for the task that I built it for the following day. But beyond that, no, it was getting worse, not better. It kept just completely rewriting stuff. That was the other thing. It would it would rewrite stuff, but make it worse. Now, and interestingly, I listened to a really interesting podcast by Kent Beck, who is a bit of a hero in this sphere, test-driven development. I mean, he kind of invented continuous integration. He is now a big fan he doesn't like to call it vibe coding. He calls it augmented coding, but he's a big fan of using LLMs to help him to build software. But I heard a fantastic podcast, not to mention a competitor, but I'm sure we can all help each other, but on a podcast called Ollcast, an interview between Jess Kerr and Ken Beck about his experience, and he said exactly the same thing. He said that he gets sucked into that sunk cost fallacy, that he finds himself saying, oh, well, let's just try something and then something and then something. But he has discovered, and I can clearly see that this is true, that what you need to do is keep throwing it away and starting again. And what you do is every time you throw it away and start again, you go back to what I was saying before, that you ask the LLM to summarize what you've just learned and persist it. So you can document what you've learned from your coding session. You throw away the code. You also throw away the chat context. So there's a whole thing about contexts and how they degrade over time. So start a brand new chat context. So the LLM is effectively, you've thrown your engineer away and employed somebody new. You know, it doesn't know anything about what just happened, but you've persisted a document that records the lessons that you've learned. And in the new chat context, you say to the LLM, read this. Read this. This documents how we would like to work. Follow the instructions in here. And there are two levels to that. There's a kind of a meta level where you say, we have decided that we would always like to move in small steps, and we'd always like to make small commits, and we'd like to always write a failing test and all that kind of thing. So that's a kind of meta level that you can carry between projects as well as between LLMs. And that's the other thing, between LLMs. So you can give it to Gemini, you can give it to SWE, you can give it to Claude, but also between chat contexts. So even if you're using the same LLM, you can throw a context away and start a new one. But you can also carry it between projects, the meta stuff. But you can also have something that's specific to your current project. So you can say, we've decided that we're building a tool that does this, and we want it to do this, and we want to do it like this. And we want the user experience to be like this. And you can take that, again, between LLMs, between chat contexts, you can throw away the code, start again from scratch, but with a slightly better context than what you had before. And because it can write code so quickly, it's really easy to throw code away, which is a wonderful, wonderful practice anyway. And it's something that people who do katas like to do. You know, you do the kata and then you throw the code away and then you start again from scratch. And it's actually based on a martial arts practice to do with dojos and wax on, wax off and all of that. And I'm not an expert, but you know, the idea that you keep doing the same thing over and over again, and you build the muscles, you build the muscle memory as a result. This is really easy to do with LLMs. And I think that when you get it right, when you have the guardrails in place, where you have the persisted practices that you carry between projects and between chat contexts, and you really pay attention to what you're doing, so that what you're doing is getting that balance between the speed of the LLM and your own good practice and what you know about how to do good software development. Because the speed of the LLM on its own very quickly becomes a handicap rather than an advantage. So you have to be able to recognize when you can harness that speed and when you shouldn't, because actually it's just going to take you very fast in the wrong direction.
Yeah. I mean, like throwing code away and starting from scratch. I had a very smart guy I worked with, and he always said, code deletion is the highest form of engineering.
Mm-hmm.
It's like, take pride I delete 100,000 lines of code, or to like replace them by smaller amount of code. Like that was a thing. So like that makes sense.
Yeah.
Going back to like, I wanna go back and shift a little bit and talk about like test-driven development today. And how do you like, what is your opinion about the state of the practice today in the industry or in the teams that you work with? Is it thriving? Is it like forgotten? How do you see it today, and how do you see and what's your opinion about that?
Not thriving, but not forgotten. I'm not sure it's ever thrived, to be honest. I think it's always thrived in small pockets. I think there have always been advocates who have been able to experience the power and the benefit of test-driven development, but have struggled to spread that practice. And I don't think that's a problem we've ever really solved. So everywhere I go, I meet people who are enthusiastic about test-driven development. But I also meet people who absolutely aren't. I meet people who've never heard of it. But even the people who are enthusiastic about it often have never quite experienced its real power. So, I mean, I'll give you an example, and I don't think this was unusual then, and I don't think it's unusual now. About 10 years ago, I worked for, and this was when I was first discovering TDD. I worked for a company that claimed it was one of the company practices, that everybody did TDD. And they didn't. What we actually all did and again, even this wasn't ubiquitous, but most teams did this, was we had very comprehensive suites of unit tests. And most of the code bases had comprehensive suites of unit tests that were built into pipelines. But when those tests failed, that code still got deployed. That's the first thing, very common. But also, those tests were written after the code was written, not before. So that those tests weren't driving the development of that code. So that's not actually test-driven development. And also, the tests were cookie cutter. They were always the same. And they followed the same pattern every time. And the same things were tested every time. And everything was tested, and those test suites were never revisited or pruned. So, for instance, we'd have like plain old data objects that all they had on them was getters and setters. All they were doing was carrying data around the system, and those getters and setters always had tests attached to them. It was just unnecessary. It wasn't adding anything. What it was doing was bloating those test suites, so they were slow to run, which is why when they failed, it didn't stop deployment, because that would have been too slow. But it's worse than that. It's not just that those tests weren't really fit for purpose. It's not just that those tests weren't driving development. It also was tedious to do it this way. It felt like we're just doing it because we've been told to do it. We're not getting any benefit from it. But a whole bunch of people are coming through quite a large company and being told this is TDD. And then they're going and they're saying, well, I don't like TDD. TDD is a waste of time. You know, I don't do TDD because I did it at this place and it was just ridiculous. Like, we were just doing this for the sake of it and we weren't getting any benefit from it. And that's a really, really common experience. And I think the reason it's a common experience is because doing test-driven development well, doing it in the way that it was originally designed, where you work in tiny, tiny steps, you always write a failing test before you write the code to make the test pass, that the tests fail meaningfully. They don't just fail because they don't compile. The test is failing in such a way that when you make it pass, that's meaningful. You've made something work that previously wasn't working, and you can see and understand the difference, and you can see that you've made a meaningful difference. And doing all of that at first feels very slow. And unless you're doing it very well, and then you're not going to see a benefit. It's not going to feel beneficial. It's going to feel frustrating. And in order to get really good at it and really see and feel the benefit, you really have to put quite a lot of effort and time into that. And typically, it's not an easy thing to learn on your own. The best way to learn it is by pairing with somebody else who has that experience. And that is slow. That process of learning is slow, and it really thrives on pairing, and pairing is very hard to sell. Anything that's slow is hard to sell in the commercial environment because people don't want to move slowly. And if you've even got one piece somewhere in the chain that is saying move faster, and if that is somebody who has power, it's very, very difficult to push back against that. And I think that's why. That's why it's still not ubiquitous. It's still largely misunderstood. A lot of people don't see the benefit. A lot of people don't feel the benefit. Not only do they not see or feel the benefit, they've had the opposite experience where they've experienced what they were told was TDD that actually made their lives worse rather than better. All of that adds, and we're all impatient as well. You know, I mean, you have to be patient, and that's hard. So it's not just, I'm not even just blaming it on people who are coming and hitting us with deadline hours, where we are ourselves impatient, as well as working for overlords who are impatient. And all of that makes it really difficult. And I'm very lucky because I managed to get myself in the position. It was hard, but I've managed to get myself into a position where it is my job to go and spend time with people and have the time to show them how and why TDD is a really useful, powerful tool. But people like me are rare. Experiences like that are rare. And even though it's my job, it's still hard for me to find those gigs. It's not a done deal. So yeah, unfortunately, it is not ubiquitous, and there's always pushback.
Yeah, no, I mean, like moving slow, like starting slow to like go slow to go fast, optimize your workflow first, make sure that you're like, you set yourself up for success is, I think, the most common advice, but the most under followed advice I have seen teams take. Where like, hey, we should set ourselves up for success, but then we're also we need to deliver today, and it's fast, and like,
Yeah.
it's a vicious cycle, and it's hard to break.
Well, there's that feeling of frustration and despair, you know, and we've all had it. So even if we're not just talking in the context of test-driven development, we've all had that experience of working on a code base that is in a poor state of repair, that has issues, that are slowing us down. There are problems that are making it difficult for us to add new features, for us to fix bugs, for us to deploy, for us to scale, whatever. We've all had that experience. We've all had the experience of being able to see areas that really need fixing. And if only they could be fixed, our lives would be better. And the result of the problem, so like the common term for it is technical debt. The result of that technical debt is that we are actually moving slowly because there are so many bugs, because it's so difficult to deploy, because our pipelines have ground to a halt, because we can't scale, because we can't add new features. We're actually moving slowly. And it is because we didn't move more slowly a few steps ago. And even though we know that, we still can't manage to find the will and to do something about it, because that would slow us down even more. And you'll have had that experience, not even in code, like maybe with your own to-do list, that you really know that you'd really like to take a few days off to fix, like, you know, maybe like to go through those emails, those thousands of emails that I've got, for instance, that I know need my attention, and I know that I would really like to do it, but I haven't got time. I'm too busy.
So I want to actually ask you a question about that. Like, maybe two sides to this question. What is like? I'm sure during in your career you have seen and coached teams that are like in that state where they are like got to a halt almost, or like but then are also cannot justify, let us get from under the waters, like, and do something different. What is your advice to these teams? How do they recognize that they are in that pattern, and how do they get out of it? And then the other side of this question is that if a team is forming and starting something from scratch, what advice do you have for them as to when to bring this engineering rigor in place so that they can avoid getting into that situation ever?
Yeah. So how to recognize that it's a problem? Pay attention to what's slow. Pay close attention to what's slow. What is slowing you down? And then try to measure it. And measuring is a tricky thing. but try to think, and you might be using Dora metrics. It's going to be different for each team. But think about what can you measure, and then think about what levers can you pull that might make a difference. So, for instance, and then crucial, think about how you can do that in tiny steps. Because one of the problems is that people recognize they have a problem, they want to fix the problem, and they feel like, because there's never any time, what they need to do is just put some time aside for fixing the problem and then do as much as possible all at once. So, like, for instance, we're going to put 2 weeks aside to do some refactoring. No, bad idea. Because what you're doing then is you're doing a big chunk of work instead of a small chunk of work. One of my favorite phrases in this space is many more, much smaller steps. MMMSS is the short version from G-Paw Hill. Just look it up. Look up G-Paw Hill MMMSS and you'll find G-Paw waxing lyrical about it. But many more, much smaller steps. So if you have a problem with your code base, if you've got an area that you really want to refactor and you can see there's technical debt there, don't stop for 2 weeks and do it all at once. Because typically what you're doing there is, if you think of the analogy of fixing a car engine, what you've basically done is you've taken the car apart and now the engine is in pieces at your feet. And now somebody says, quick, take me to the hospital. You're like, I can't. The engine's in pieces all over the garage floor. It's going to take me a long time to put it back together again. People often use that approach when they're refactoring. They pull the whole code base apart and now they can't put it back together again. And they also might lose sight of what they're trying to do in the process. Instead, make a tiny fix. So one of the techniques that I teach is how to refactor in tiny steps. Just change a name. Just extract a method. Do a tiny thing that means that the tests will still pass. Every change you make should be deployable, and every change should be tiny. So you make a tiny change and then you run the test. So after you've made that change, the code should build and the test should pass. The test should always pass, and the code should always be deployable. You should always be interruptible. G-Paw's got some great little kind of schematics about how agile you are when you move in tiny steps, and how when you move in tiny steps, you don't have to move in a straight line. So you could take a 300-yard step, if you were a giant, in one straight line, or you could take 400 one-yard steps that actually get you from A to, they both get you from A to B. One of them was 400 one-yard steps, one was one 300-yard step. But the problem with the one 300-yard step, even though they both might end up in the same place, and one of them took you a wiggly route and one of them took you in a straight line, you might not have wanted to end up a straight line 300 yards away from where you started. You might want to end up in a completely different direction. And the thing is that when you're in the middle of that 300-yard step, you can't switch directions. You can't stop.
Agree.
You can't do something else. So the tiny, tiny steps, when you're trying to improve things, do everything in tiny steps. So literally in terms of lines of code, but also in terms of what you're going to change in your team's processes. Don't change everything all at once. If you've never done TDD, don't say from Monday the whole team is mandated to always do TDD and nothing else, because your team aren't going to have the skills to do that. Do it a little bit at a time. Really nice. So I'm seeing that we're running out of time. Just one thing I'll say, a really nice technique that I recommend to teams who want to improve things and who don't have good test coverage and maybe haven't been using test-driven development. The next time you have a bug to fix, before you fix the bug, write a failing test that surfaces the bug. The reason this test is failing is because there's a bug. And then, in order to fix the bug, you have to make the test pass. Or it might be a whole series of tests. But you fix the bug by making the test pass. And now suddenly you've got better test coverage. Not only have you, and you did TDD, that is TDD, but also the test that you've got is testing a real thing that you know is a likely possible problem. It's not a random abstract test that tests a thing that maybe nobody cares about. It's testing a thing that you know was a problem because you proved it was because it was a bug. And that's a really nice place to start. Just one test that before you fix the bug.
Makes sense. Like, I like to tell like the teams I work with, or as well as like think about it as, okay, you're in a bad situation right now. Let's first stop the bleeding. Like start do some practices to stop the bleeding, which you said like just add a test whenever you had a bug, make sure that you have coverage for it, you can catch it, stop the bleeding.
Yes.
And then once you stop the bleeding, like over time, slowly just like pick one thing from the past to fix. If you have time, and like, keep doing that, over time, things will get better.
Yeah.
Or
Yeah.
in the worst case, if you don't get time to go address the past, if you give it enough time by stopping the bleeding, you would have written most of the code again anyways in probably a couple of years, and that would have gone.
Yeah.
Is that
And
like
also,
similar to what you're thinking?
yeah, and also you said, but even I would add to that as well that when you say if you have time, if the change that you make is tiny, then you do have time. So, you can, every time you see a little problem in the code base, fix it while you're there, but a tiny fix. Just extract a method, just rename something. You've always got time for that. The smaller the steps, the more likely it is that you will have time. The bigger the steps, the less likely.
Absolutely. Absolutely. Well, thank you so much, Claire. It was so much fun talking to you and learning from you today. I am sure our audience would love to hear more from you or find you. If they were looking to hear more of you and find you, where can they do that?
The easiest way is to go to queenofquestions.kit.com, and Queen of Questions is hyphenated, so queen-of-questions.kit.com. That's me. I'm the Queen of Questions because I love to ask questions. That's my newsletter, it's my blog, and there are links from there to everything else. And it's also worth me mentioning that I will be in Amsterdam in November. Now, I know you're based in America, but you might have people who would like to come to Europe, and you might have listeners in Europe, and Amsterdam is a great place to visit. But I'm running 2 workshops in Amsterdam in the 3rd week of November, and one is a 2-day workshop on how to use test-driven development with agentic AI coding. So very relevant to what we've been talking about today. The other one is a 1-day workshop on how to handle the technical and technical leadership. And I'm also doing a TDD and AI workshop in the 4th week in November in Berlin at the Software Architecture Gathering. So, but you can find links to all of that if you go to queenofquestions.kit.com, which then links out to everything else.
Well, thank you so much. Maybe I'll come in Amsterdam. I don't know.
Yeah, come to Amsterdam.
Thank you so much. It was so much fun talking to you.
Thank you. Thank you for having me. It's been really, really fun to talk to you as well.
Thanks for checking out the Bug Bash podcast. If you want to reach out, maybe with an idea for the show, or maybe you want to be on it, send us an email at bugbash@antithesis.com. Or, if chat's more your style, head over to antithesis.com and scroll to the bottom, where you'll find the link to our Discord. Until next time.